Hello, class. Welcome. So today I wanted to do a quick kind of coverage of this test review, both as an answer key for you, so you can check your answers and make sure you're doing the questions correctly. But also, if you're stuck, hopefully this can help you get unstuck. My recommendation on the review, how you should do it, is work through it. No notes, nothing. Treat it like a test. Give yourself probably 30 minutes, I would say. And if you're making really good progress, if you're getting through everything, you're like, yes, this makes sense, I totally get it, then awesome. Keep going. But if you hit 30 minutes and you're stuck and you haven't really done anything, you're not building momentum, that's a sign that is telling you, hey, I have not done the work I need to in order to prepare for this test. So then grab your notes, use your notes to go through and correct any work that you've done, go through and fill in answers that you haven't done yet, and use it as an opportunity to study as you go through. So this test is on systems. What a system is anytime we have multiple things, kind of the way I like to think of it is multiple requirements. For instance, when you're buying a car, you have multiple things you're looking for. For instance, for me, I know I need it to be a truck because I do things that require trucks. I like to go off-roading. I like to haul things. I like all of these things that a truck is what I need. But then we have other things that come up. For instance, for me, I need a four-door. I'm looking at having kids, and also I just like to have the storage space. Four doors is a must. Your requirements might be different. And it comes down to a system is how do we define those mathematically? So the very basic system that we're working with is a linear system where you're given two lines and you have to find what point they have in common. Do they share all of their points or do they share no points because they are parallel? So for all of these, answer the question completely, show all of your work. While your work is not necessarily graded as heavily, what it allows us to do is it allows me to look at it and say, hey, you made this little mistake, but you were on the right track. You were doing the right thing. And it just makes it easier on me that I don't have to sit there and spend 20 minutes trying to decipher what you're doing. I can very clearly look and go, oh, the mistake happened here. You were 90% of the way there. You deserve more points. As opposed to if I just get some random number and it's like, you had good logic. You had a good reason for doing that. But I can't tell that. Well, that's where the issue comes in. Kind of this caution of silly mistakes. I know a lot of people will use something like stupid mistakes, like, oh, I'm so stupid. How could I have done that? I don't like that because it's not stupid to make a mistake. Mistakes are really important. It's how we learn a lot of things. But silly mistakes are ones that if you would have just looked at it for 2 seconds, you would have gotten it. You would have realized, oh, I forgot a negative. Oh, 2 plus 3 is not 4. Little things like that. That's what we're talking about when we say silly mistakes. And they happen a lot whenever we start giving equations, especially if they start looking like this, where you need to manipulate things in order to do stuff. That's where we start seeing silly mistakes. So, question 1. We need to graph these two lines. Graphing lines should feel good. It should be easy. Got a y-intercept of -1. Then we go up 4 over 1. And come in and connect your lines. Let's see. That is pretty close, but precision matters. And let's see, will the line, there we go. That looks much better. Some things to note on the grading. I will be very strict on make sure that your line gets off of the grid and that you have these arrows at the end. Details matter. Discipline equals freedom. As you do things well, you get more reward from it. So make sure, get those arrows all the way off of the grid. So we got line number 1, and then line number 2, x plus 2, and we go up 1 over 1. Hey, we should notice that point was shared between the two of them. And as I mentioned a moment ago, when we're looking at a linear system of equations where we have 2 or more lines, we want to know what point do they have in common. Now for the joy of, will my line snap? Pretty close. Let's just move it a little bit. So we've got our 2 lines, we graphed them. Check, check. Then we're looking at what point is shared between the 2 of those. Well, that is the point over 1, up 3. This is another detail. The details matter. This is a point. You have to have these parentheses around it. Otherwise, you're just listing the numbers 1 and 3, and I don't know what those mean unless you are specifying this is a point. So this is our basic part of solve by graphing. This is the bulk. The really important part is down here. Consider your solution above and prove it. Prove that that's correct. In class, the way I've said this and written it down is by saying check. Because you are checking your answer. You're making sure, is this true? So going back to that analogy of buying a car, these equations are both defining parameters, things that would make you happy. For instance, I want a 4-door and I want a truck. So then there's infinitely many options out there for vehicles, but my solution, say Toyota Tacoma, what I bought. Does the Toyota Tacoma satisfy being a truck with 4 doors? Well, that's what we're looking at. Is this true? Well, yes, it is in fact a truck, and it does have 4 doors because I got one with 4 doors. We're making sure, does this point lie on both of those lines? So we just plug it in. Does 3 equal 4 times 1 minus 1? Well, 3 does in fact equal 4 minus 1. Check. Does 3 equal 1 plus 2? Yes, 3 does in fact equal 1 plus 2. Boom, we're good. On your test, if you were doing a question that looked like this would be worth 6 points. If this was your test, in fact. This would be a 6-point question. You would get 3 points here for the answer. Somehow would be distributed between writing this point and drawing the graph. And 3 points down here for checking. Something like that. That's not the actual scoring of your test, but it's a ballpark. Kind of lets you know where I value points, where I think things are important. Next up, these 2 questions. These would have something like 6 points each. Maybe you're noticing that I value all 3 solving methods equally. There's not one that I go is significantly better. I think in reality, questions 2 and 3 solved by substitution and elimination, I think they are the more useful. These are the ones that you would use in real life more often, but solved by graphing is just as valuable. It will answer just as many questions. Now, on your test, you have a choice. Very similar to your quiz. You have the choice of how did you want to solve it. You could pick my advice. In our notes, we had different ways of defining which ones are best. Notice up here, both of these equations started off in slope-intercept form. These were y equals mx plus b. If they're both looking like that, we probably want a graph. If we come down here and we notice one of these is already solved for one variable, that leads us to where we should say, hey, I'm going to use substitution. Because substitution is saying this thing is equal. It is exactly the same as that thing. Here, y is exactly the same as x plus 4. So anywhere I see y, namely here, I can replace that with x plus 4. Just like if you're baking, if you are out of a certain ingredient, you can sometimes substitute with other things. You want to be careful with this because some substitutions will drastically change the flavor. For instance, about a year ago, my wife was baking some cupcakes and we were out of, I believe it was eggs. And we read online that you could substitute applesauce for eggs. It might have been something else, so don't trust me on this. But also don't trust it because those were the most disgusting brownie or cupcakes we'd ever made. So sometimes you have to be careful with real life substitutions. Here in math, you just got to be careful of making sure you distribute. Because this y and that x plus 4 go in the same place, we're still multiplying by 3 here. So when we rewrite this, 4x plus 3 times x plus 4 equals negative 9. You then need to distribute that 3. Now, in class, I mentioned using this thing called the area model, which you might have seen when you were younger learning multiplication. You are definitely going to see it here in Unit 3 when we start talking about factoring quadratics and just dealing with quadratics in general. So we set it up like this, and each box relates to one value. So every column goes to one value, every row goes to another. Then we can ask, what's 3 times x? Oh, that's 3x. What's 3 times 4? That's 12. So now I know that this thing here is 3x plus 12. So 4x plus 3x plus 12 equals negative 9. Combine like terms and simplify. I'll bring this up here. 7x equals, subtracting my 12 over, I get negative 21. I'm then going to take and divide out that 7. So x equals negative 3. Now I've found one value by substitution. I'm going to take this value, because I know what x is now, I'm going to plug it into one of these equations. You get to choose. It doesn't matter. You could plug it into either equation. You get the exact same answer. But here in Algebra 2, what we're looking for is, can we make wise decisions? We know you can do math. You've done solving. You've plugged in variables. You did all of that in Algebra 1. Now is your chance to say, hey, can I do it wisely? Can I do it in such a way that I'm making a choice that saves me time and effort? So if I want to plug in x to get y, doesn't it make sense to plug it in here where it's already solved for y? Yeah, that seems like a better choice. So y equals negative 3 plus 4. Well, negative 3 plus 4 is 1. So now I'm going to boldly state my solution is the point negative 3, 1. But I'm not finished. Just like this problem up here, where I did my problem solving process, I had to graph, I then had to check. We always want to check, because what if I'm wrong? Wouldn't you rather catch yourself making a mistake than wait for me to catch it with my red pen? I don't know about you. I always want as many points on any test that I'm taking, because as right now, passing my class is beneficial to you. But going forward, a lot of careers have tests that you have to pass. My wife is an actuary. There's a series of 6 tests. that she has to pass in order to stay in the career. My dad is the director for the power company, all of the different career paths, whether lineman, estimator, any of those, you have to pass tests in order to qualify for doing the job. So we want to get points. We want to check our answers and make sure that we're correct. So plug it into both. Does 1 equal -3 plus 4? Well, yes. -3 plus 4 is 1. 1 does in fact equal 1. 4 times -3 plus 3 times 1 equals -9. Well, does -12 plus 3 equal -9? Yes, it in fact does. So now I can come back and I can throw a box around my answer because that is a box-worthy answer. It is correct, and I know it for certain. So that is solve by substitution. In reality, it's the one that we use the most. It is easy. You can generally do it pretty quickly too, as you practice it more. In my opinion, question 3, well, there's only one option left, solve by elimination. I think elimination is the most fun because it requires mastery of the algebraic topics that you have been learning for the last 3 years. So when we look at this thing, I need to take this value and I'm looking for some way of eliminating either my x or the y's. So what we want to do is look and see, is one of those two values that are circled, is one of them a multiple of the other? In other words, could I multiply one of them by a number and get the other one? Hopefully, you've been screaming, yes, please move on. I know the answer. I have to multiply 4 by 3 to get 12. Great. That's my hypothesis. I think I need to multiply the top by 3, make it negative so that they cancel. But looking at 2 and 5, doing the same kind of mental exercise, I would choose to not deal with the 2 and the 5 because in order to get 2 to multiply to 5, you need to use a fraction and it's going to be a lot of work. This kind of process of, oh, I need to multiply here the top by 5 and the bottom by 2. This is what you would be doing in the honors level. So I know I need to take this top equation and multiply it by -3. Now, I'm going to rewrite this entire statement with multiplying by -3 and the bottom equation. This is a really common silly mistake location where you want to be disciplined. Multiply that by -3, so I get -12x plus 6y equals 0, and 12x minus 5y equals -6. So this is where that discipline equals freedom comes in. If you're disciplined, if you rewrite the entire thing once you do that multiplication, you're less likely to make a mistake because you're kind of giving yourself this solid, like, I need to focus right here. What I see a lot of people do is they'll multiply this by -3. They'll write it right below, and then they'll start adding, and they'll add this 4x, the 12x, and the -12x all together and end up with a really weird answer. So now we've rewritten it. We're going to add straight down 12x plus -12x. That is 0. We have no x's. We eliminated them. 6y minus 5y is just y. Y equals 0 minus 6, -6. So I've acquired my y value. Now I can just take it and plug it back in to this statement. Once again, once you find one of your values, you can plug it into either one, the top or the bottom. It doesn't matter. Personally, right now, I'm going to choose the top because 6 times 2 is 12. I know that one very quickly. It lets me deal with some smaller numbers. So 4x minus 2 times negative 6 equals 0. 4x plus 12 equals 0. 4x equals negative 12. X equals negative 3. So same process as before. This check step is the same whether you solve by graphing, solve by substitution, or solve by elimination. So I'm going to state my solution. My solution is negative 3, negative 6, and I'm going to check it. So if I plug them in, 4 times negative 3 minus 2 times negative 6 equals 0. Well, negative 12 plus 12 equals 0. Well, yeah, duh. They are obviously negative. Something plus itself cancels out. 12 times negative 3 minus 5 times negative 6 equals negative 6. Well, 12 times 3 is 36. Make it negative. Plus 30 equals negative 6. Well, yes, negative 36 plus 30 leaves only negative 6. So that is a box-worthy solution. So this front page here, if we are looking at it as a whole, would be something like 18 points, which I believe on your test is out of 40 points. So right here, this front page, which is essentially the quiz that you took last Monday, is half of the stuff that we want you to know. This is the really important part because if you understand this front page, the rest of the test is just taking, okay, use that skill, but do it in this context. Do it over here. So this front page is really important. You want to make sure that you really know how to do this here. Now let's take a look at our word problem. So hopefully you remember from in class, you can look at your notes. I'm going to go over this one quickly. The general advice I always have whenever you're dealing with a word problem, ignore the names. Simplify them down. A very common thing that people will do on word problems, especially on state testing, they'll do this a lot. They're going to give you names that they intentionally know are going to make you stumble a bit. Especially, like for me, I'm a teacher. I get thrown 200 names a year that I have to somehow remember and know how to pronounce correctly. Some of you can attest. I am terrible at that pronouncing correctly. So, on word problems, come in here. What are you doing, iPad? Come on. I will come in and I'm just going to get rid of the names because it's a test. I'm timed. I have to do it quickly. I'm not going to spend 10 minutes beating myself up over the fact I can't decide on how I want to pronounce that second name. I'm going to call it M and A. I'm going to do that every time I see those names. And I do it out of kind of the mathematical ability of we're trying to make this problem easier to deal with. So when we see a problem, you should read it 3 times. That is my advice always. You should read it once with no intention of doing anything. The second time you read it, you should read it with the goal of trying to answer the problem. Then you should read it 1 time afterwards to make sure that you actually answered the question that was being asked. I'm going to let you pause the video and read it a few times. And sometimes you might need to read the question 10 times before you really even understand what you're supposed to do. Then you're going to read it after you do the problem. So read it as much as you need until you think you have an idea of what it's doing. As I'm reading through it, I'm just going to kind of jump into the I've read it, I have the kind of subconscious work done, now I'm just doing the problem. So M and A are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. M sold 13 boxes of oranges and one large box of oranges for a total of $175. A sold 8 small boxes of oranges and 8 large boxes of oranges for a total of $248. Find the cost each of one small box of oranges and one large box of oranges. So, first thing we need to do, we need to define some variables. Because what we want to do is our variables should tell us both something about the answer. So in this case, find the cost of each. So our variables should say something about cost of. I'll write that on both of them. Cost of. So our variables should have something about the answer, but they should also tell us something about the problem because it's a variable. Our goal is that a variable lets us condense a story problem into being something smaller. So as you're reading through this problem, you should start to pick up on, okay, there seems to be two different things that is a choice because your variables are choices. In this case, your choice is a small box of oranges or a large box of oranges. Now, you can pick. X or Y can be small or large, it doesn't matter. So I'm going to call X the cost of a small box and Y the cost of a large box. Now, this is a little bit of just the way my brain works and also knowing how math answer keys work. Mathematicians making an answer key are going to do it in order. Whatever came first is X, whatever came second is Y. That way we have uniformity in our answers. My answer should match Ms. Cottrell's answer, which should match Mr. Miller's answer, which should answer the same thing if we randomly threw this to Mrs. Gelsinger and she had to do it. We're going to do it in order. So now that we have these variables, we can come in here and I'm going to replace some stuff. So let me come in. So anytime I see this small box of oranges, I'm not thinking of small boxes of oranges anymore. I'm thinking of X. Anytime I see large boxes of oranges, I'm thinking of Y. And what this is doing for us is this is hopefully eventually taking this giant paragraph and it's shrinking it down to something that we can write as two, well, based on this unit, linear equations. So we're slowly just cutting away the story and leaving out some equations. So for M, I'm going to call it equation 1 and A is equation 2. So 13x plus y equals, well, our final answer is it should be something about cost. How much money did those boxes add up to? 175. Equation 2, I'm talking about A. Well, A sold 8 small boxes, 8 large boxes for a total of $248. So we've taken this giant paragraph and we've cut it down to being these two equations right here. So now solve the equations. We need to find what those two variables mean. And at this point, this is the beauty of math. On the front page, we dictated. You had to solve one by graphing, one by substitution, one by elimination. Because we want to see, do you know those 3 skills? This is a word problem. This is something you could encounter in your real life. Granted, you're going to probably not encounter it necessarily in this situation, but you can extrapolate the skills. You get to choose. If you want to solve for y, you can graph these. You'll get an answer. It's got a nice answer. They're whole number values. You can solve by substitution. You could solve by elimination. You'll get the exact same answer. But you have to choose. Now, I'm going to show you something that is slightly different than what we did in class because I want to hammer home a different point. It's the same process, I'm just doing something slightly different. Because one student asked me in class, could you divide? Because on elimination, we're looking for what can I multiply one of the x's or one of the y's by to make them cancel? Well, multiplication, I'm going to write this here. Multiplication is division. They are the same thing. When you say multiply, y there, multiply and division, same thing. So when we see this problem, one student asked, well, could I divide by 8? Or multiply by 1/8? Yeah, make it negative so that they cancel. Because their goal was that they wanted to cancel y and 8y. Yeah, that works. And we like fractions in this class. Multiplying by 1/8 is exactly the same as dividing by 1/8. Or sorry, dividing by 8. So if we did that, we now have, remember that discipline, 13x plus y equals 175, and negative x minus y equals 248 divided by 8. You can probably hear me grabbing my calculator because why not? I get a calculator. Why not use it? So my y's cancel. Y minus y is 0. So I get 12x equals 175 minus 31 is 144. Solve for x, I get that x equals 12. Now, what I want you to do right now is pause the video and plug that back in and find your y value. I'm going to take a drink real fast because I've been talking for quite a while. I want to make sure I don't lose my voice halfway through the video. So we take this y and we plug it back into our statement. I'm going to plug it into the top one because it's already got y by itself. I don't have to do anything special. So 13 times 12 plus y equals 175. 13 times 12, you can mess with this, you can do it yourself. Where'd my pen go? 156 plus y equals 175. So I'm just doing that in my head. Now, I have a calculator. I can always check it, but it's good. Test your brain. See if you can do that 2-digit multiplication in your head. My calculator agrees. It is 156. Solve for y. I'm going to subtract that 156 over because I don't want it on this side. I move it with subtraction. And I get 19. So now I have my points, or I should say point, that I'm going to plug into both equations. 13 times 12 plus 19 equals 175. And 8 times 12 plus 8 times 19 equals 248. Now, grab a calculator. You can plug these in as is and see, do they come out as true? 13 times 12 plus 19, that is in fact 175. 8 times 12 plus 8 times 19, that is in fact 248. So that is my answer, and I'm going to box it a ton. So there's no possible way we don't know this is our solution. But this is the solution to this kind of pared down statement. They gave us the question in a paragraph. We need to answer in a sentence. What does that 12 and 19 mean? Right now, pause the video and think about it. Don't come back to the video until you have an answer of what you think 12 and 19 are. And it should be based on what was X and what is Y. So our X and Y are the cost of a small and a large box, respectively. So when we write our answer, we would say something like, the cost of a small box is $12 and a large box costs $19. And we can see how this might incorporate into your real life in some various situations. This is kind of the base level of where it goes, and it can go up from there. On this question, in class, I told you it should be colored this side. So when we look at that and we're writing our equation, we're looking at this. First off, we know it's a linear equation. Why? And then ask yourself, are you coloring above or below the line? If you're coloring above the line, then that means that your y is greater than. Now, since we have, you can see here, zoom in real quick, we have a dotted line. That tells me that the points on this line do not satisfy the statement. We can get as close as we want, but if we touch the line, we are outside of the property. Same idea when you're out on a hike. If you see a fence, you can go up to the fence. You can go right up to it, but the second you touch the fence, you are legally speaking trespassing because you have crossed this imaginary line that define, well, not imaginary if it's a fence, but you've crossed this line. You can exist anywhere on one side, but as soon as you touch the line, you are now on the other side. Same thing here. So y is greater than, well, what's the equation of this line? Well, first we need the slope. So between these 2 points, I'll stay zoomed in here. So slope is rise over run. So it's the change in y up 4 over 2. Well, 4 over 2 is 2. So y is greater than 2, that's not my pen, 2x minus 2, because my y-intercept is at -2. Let's see, sorry, I forgot to mention. A question like this would likely be worth something like 8 points. A question like this would probably be 3 points, I believe. Something like that. So, this page here, worth 11-ish points. So, thus far, you're at 29 out of 40 points, which would put you, if you could just do these first 2 pages, that is a 73%. So we move on to this last page, This is one of those bigger questions that's really hitting on, can you do all the stuff that we were just doing, but can you also do it with the fact that this is an inequality? And when we're dealing with inequalities, inequalities are telling us that we're not as restrictive. So it's like a normal equation. Like, let's think of the equation y equals 5x plus 2. The solution to anything is what makes it true. Or kind of when we talk about inequalities, the analogy I used in class is what makes you happy. So with an equation like this, y equals 5x plus 2, it is very strict. It is that person that you talk to who is like, no, I will only be happy if you do this. I will only be happy with my birthday cake if it is a lemon cake with raspberry filling with a buttercream frosting that says my name on the top in black icing. Like, that's super specific. Most of the time, we're not that specific. As humans, we tend to have much more of a inequality approach. That when we're looking at something like these, for instance, I care that my cake for my birthday is lemon with raspberry filling. I don't really care about the details after that. I don't care if it's a round cake, a rectangle. All these other things are not important to me. I'll accept anything as long as it's raspberry filling and a lemon cake. That's an inequality. That's what we were graphing back here, is any of these points up here in the pink region, any of them will make this statement true. For instance, one of the things I talk about in class is let's pick ridiculous numbers. Let's pick the coordinate negative a million, positive a million. Pick insane numbers because insane numbers make the details fall out. So, looking at this, is a million greater than 2 times negative a million minus 2? Well, if you had $1,000,000, is $2 more really going to make a difference? No, I can kind of ignore it. So a million is greater than 2 times negative a million. Hopefully you've already caught on to the trick here of, well, negative a million. It's amazing how the zeros start to get you. Is a million greater than negative 2 million? And if you're still not sure, if you don't know how to answer that question, ask yourself it this way. Would you rather have the amount of money that it said greater than? So in this case, would you rather have $1,000,000 in your pocket or negative 2 million? As someone who has lived life, hopefully any parents watching this, the answer is you want to avoid debt as much as you can. Now, obviously, there are some good debts. There are things like college, where you go and you have to spend a lot of money that you don't have yet, but you have the hope that you're going to have it someday. That debt is not bad. Same thing with buying a house. But if I could choose, like, would I rather have $200,000 or $150,000 in debt? I'd rather have $200,000 than that debt most of the time. So that's our inequalities. So now, when we look at something like this, a system of inequalities, well, we mentioned earlier, a system is multiple things. We have multiple requirements. So, for instance, looking at this, I've got two different statements. I've got y is greater than this, and I've got this thing in standard form I'm going to have to manipulate. When we're looking at this is, for instance, anytime you're doing anything with someone else. For instance, my wife and I have to decide what we're doing for dinner tonight. We have some parameters. For instance, I love Mexican food, but my wife doesn't like Mexican food. So that satisfies one equation, it doesn't satisfy the other. So we both can't be happy if we choose Mexican food. That's what we're looking for here, is what numbers make this equation happy and this equation. So step one here, we need to solve that second one for y. Now, at this point in the year, this should be easy. This should be something that you're not even thinking about for solving this thing out. You should be able to follow along with what just happened and be very confident. The only thing that I would say might mix you up is the fact that I switched that inequality. If you are looking at this problem and you don't feel confident, if you're looking at it and you are going, how on earth did you just take negative 6x minus 4y is greater than 12 and get y is less than negative 3 halves x minus 3? If you're confused by that, you need to come in and talk to me, because the rest of this year is going to hurt worse and worse if this is not automatic. So make sure this is not a, hey, you're going to fail, I'm going to kick you out of the class. This is, I want you to have the best year possible. And I know that that can only happen if you know how to do this very quickly and completely understand it. So come in so I can help you if this step here was hard. If getting to that statement seemed difficult. Now, we're looking at it. Here's a hint. If they give you a graph, you probably want a graph. It's going to help you with answering it. So we graph both of these lines. Y is greater than 2x plus 4. 1, 2, 3, 4. Up 2 over 1. We'll see, that might snap close. This is the one time where you who are working on paper have an advantage. Ruler, you get to choose beforehand where the line's going to go. So we draw our line, and also note, it's got this greater than or equal, so I made this a solid line, because that equalities says, hey, you can be on the line. For instance, if you're waiting for a bus, generally speaking, they'll have a place where the bus is going to drive, and there's a line on the ground that they say, hey, don't cross that line. If your toe's touching the line, you're probably fine. You're not going to die. You're not going to get hit by a bus. You're fine there. Now, there are other times where, hey, if you cross this line, like, bad things are going to happen. For instance, in the copy room, there is a giant paper cutter, and there's a line on it. If your finger crosses that line, if your finger is even on that line, it's going to get smashed by the cutter as it goes by. So this equality says, hey, you can be on the line. Here, this strictly less than says you cannot be on the line. So we're going to graph this one with a dotted line. So instead of using the big dots to represent my points, I'm going to just do little dots so that I can connect them with my line. So we have -3, and then we're going down 3, right 2, or up 3 over 2. Now, hopefully you're looking at this and going, that doesn't seem like they're touching yet. Sometimes this happens because notice, are my lines going perfectly where I want them to? No, not at all. In fact, this one didn't even go as long as I wanted. But it executes a point. If you're doing this test, did your arrow get off the grid? Technically, yes. I'm not going to be that mean when you're looking at it. But it should be a dotted line. So I'm going to come in and do it like this. to make it dotted for us. Because it should be a nice dotted line going through, because points there don't satisfy our line. Once again, if you're doing it on paper, you'll have a much nicer time of graphing because you can just do a nice dotted line. Now, we have to ask, what points satisfy both of these? And I'll pose it to you as you've got section 1, 2, 3, and 4. You need to identify where the points that make both of these happy exist. One of the things I do when I graph these is here, I see that y is greater than. So I know I'm going to be coloring above the line. And this other one is less than, so I know I'm coloring below the line. So I'm looking for the region where both of these equations are happy. For instance, here in this first section, this line is happy because I am on that side of it. But this line isn't happy because I'm on the wrong side. It wants me to be below it. So I know 1 is not a good region to be in. And you can keep doing this. Plug in some points. Look at it and see, okay, if I picked a point here, I'm in region 2. Well, I don't make this line happy because I'm not on that side. And I don't make this line happy because I'm not on that side. So region 2 doesn't work either. Hopefully you're kind of starting to see it and you're going, oh, hey, I totally see what he's doing here. In region 3, well, I make my dotted line happy because I'm below it, but I don't make the solid line happy because I am below it and not above it. Well, there's only one region left over here. Well, I make the dotted line happy, I'm below it. I make the solid line happy, I'm above it. So notice the wording of this problem. Name one point that satisfies both conditions, then verify it does satisfy both statements. I don't care what point you pick, because when we're graphing this thing, all of these points here, and my pen's randomly deciding to disconnect as I'm shading in. I apologize for this looking so terrible. Any point that's over here, and I'm going to use, say, blue to make this nice and dark. Any point that is in that colored region should satisfy both equations. That this is that overlap. If we go back to that dinner analogy, we can't have Mexican food because that wouldn't make my wife happy. Well, I don't like hamburgers, so that wouldn't make me happy. My wife doesn't like anything spicy, so that eliminates some other stuff. But over here is this beautiful thing, Italian food. We almost always agree on Italian food. But there's other foods over here. I'm not asking you to give me a specific value of like, oh, you have to give me exactly this point. Name anything over there. I choose this random blue point because it's in the middle of the graph. So my point is over -8 up 0. So wrong pen size, -8 up 0. And verify, does it work in both equations? Is 0 greater than or equal to 2 times -8 plus 4? Is 0 greater than or equal to -16 plus 4? Is 0 greater than or equal to -12? Yes, it is in fact true. 0 is bigger than anything negative. Let's plug it into the other one. -6 times -8 minus 4 times 0 is bigger than 12? Well, negative times a negative is positive. 48 plus 0 is bigger than 12. Yes, that is true. Then, so I've proven that my point worked. Then they ask, is negative 3, negative 2 a solution to the system of inequalities? So let's look at it. Negative 3, 1, 2, 3, negative 2, 1, 2. Is that point a solution? Based on my graph, I would say no. But I know graphs can be misleading. They're not always perfect. So what I'm going to do, I'm going to plug it into both equations. So is negative 2 greater than or equal to 2 times negative 3 plus 4? And is negative 6 times negative 3 minus 4 times negative 2 bigger than 12? Well, this looks like it's outside of both, so both should fail. Is negative 2 greater than or equal to negative 6 plus 4? Is negative 2 greater than or equal to negative 2? Yes, they are in fact equal, so I'm good there. Now, if I plug this one in, is 18 plus 8 greater than 12? So is 26 greater than 12? Yeah, that is in fact greater than 12. So when we're looking at it, would my graph have led me to get this answer wrong? Yeah, it could. And this is why I am always such a proponent of, hey, be very disciplined in your graphs. What I don't want you to do is I don't want you to do your graphs really fast. And don't do them under pressure. Like, don't sit here and try to record a video of you doing the math yet. Because you're going to make a little mistake where it's like, hey, that graph would have made me say no. So that's where we need, when we do this, double check it. I will always default here to the equations because equations, it doesn't matter if my handwriting gets sloppy. Sloppy handwriting is not going to lead me very often to making a catastrophic mistake. Whereas graphing is really easy to make a mistake unless you use the calculator, which you could use a calculator to graph this stuff. And a calculator would do it perfectly. And that's why in real life we use a calculator. But it's so important that we know why is it true? What is the calculator doing to make sure that it's true beyond just being better at graphing than we are? So here, my answer would be yes. And I would say in a sentence, yes. Negative 3, negative 2 is a solution to the system of linear inequalities I'm going to use my fancy math symbol here because it satisfies both equation or inequalities. So that is the entire thing. It's the last page. So make sure as you're going through this, one, you should be feeling confident. At this point, we've had a lot of days where I've said, hey, we're learning nothing new. We're just practicing. I've given a lot of office hour times of, hey, come in and ask questions at this point. If you're stuck on this, come ask questions. So make sure, if you're not feeling confident, that is a sign right now that, hey, what I've done in quarter one isn't working. And if it's not working, that's okay. Come talk to me so that we can work on making sure that it works and that we can get you into a position where Q2, you're feeling like it's easy. It's not too bad. You're feeling that good, slight stress of growth. So make sure if you have any questions, Monday during lunch, I will be doing a help session exclusively talking about questions you have based on this video and things that you didn't get from this review / other things you might have noticed from the notes that you're like, hey, I noticed we talked about this in class, but I'm not seeing it in the review. Is it something I need to worry about on the test? I hope you've had a great weekend. I hope you've done some studying before now and that this isn't the thing that's sparking you into fear of, oh my God, I forgot there was a test on Tuesday. If it is, hey, great, start studying now, and I think you'll be fine. If you've been doing the homework and paying attention in class, you should be good. If you have any questions, please come in. I will be there before school and during lunch on Monday. Have a great weekend.